So we have one more type of calculation that we can do for strong acid, strong base titrations. Remember, we're going to look at two different types of acid-base titrations. We're right now looking at strong acid, strong base, and then we're going to look at a strong with a weak. So for the strong acid, strong base, one type of calculation, the last example that I did, is using titration data to calculate the molarity of a substance in the titration. The other type of calculation that you can do is calculating the pH at any time in the titration. So let's take another example. So let's use the same types of solutions that we were using in the previous example. Let's say that we have, for the example above, let's say that we wanted to know the pH. What is the pH in the flask after 10 milliliters of NaOH were added? So this is before we've actually reached the equivalence point. Now, in order for us to be able to solve this type of problem, we would have needed to do the problem above. You could not just start right here with this problem. You would have had to make it all the way to the equivalence point and do your calculation. So that means that you would have needed to know that the HCl is 0.3126 molar, and you would also need to know that you started with 25 milliliters of the HCl, and you would also need to know the NaOH molarity, 0.5. Again, you would not be able to do a problem like this one right here first initially. You would have had to do some other calculation before you could do this. So we're going to use a nice table again, HCl plus NaOH, making NaCl and H2O. And we want to know initially how many moles do we have of HCl at this exact moment in the titration. Our initial moles of HCl are going to be all the moles of HCl that we have in the flask, the 0.3126 moles per liter, the molarity, times the 0.025 liters, 25 milliliters that we started with. So initially, I guess I could have just looked up above there. Initially, we had 0.007815 moles of HCl in the flask, 7815. And then we have to figure out for the NaOH, how many moles of NaOH have we added at this 10 milliliter point? For that, we're going to use the molarity of the NaOH, 0.5 moles per liter, times that 10 milliliter volume, 0.010 liters. 0.5 times 0.01 is 0.005 moles of NaOH. So this is where we're at this particular time in the titration. No products yet. So what we're going to do next is figure out what the change is, how much is reacting. Now this is a strong acid, strong base, so the reaction is going to go to a completion, which means we're going to look at both of our products and we're going to figure out which one is the limiting reactant, which one do we have the least of. Our limiting reactant is the NaOH. That's the one that we have the smallest amount of. Whatever our limiting reactant is, that is how much our change will be. All of that limiting reactant is going to be gone. That limiting reactant is dictating how much of the HCl is actually reacting and how much product we're making at that time. So to figure out what we have for HCl at the end, it's going to be 0.007815 minus the 0.005. So at this particular time in the titration, we are ending with 0.002815 moles of HCl. Remember, this is in moles. And we have 0.005 moles of NaCl and 0.005 moles of H2O. Our goal, remember, our goal here is to figure out what is the pH. So we have determined that inside of this flask we have HCl, we have NaCl, and we have H2O. Of those three things, which one is contributing to the pH of the solution? The HCl is an acid. NaCl is a neutral ionic compound or neutral salt. Water is neutral. So the HCl is what is going to contribute to the pH of the solution, and that is what we need to use to calculate the solution's pH. HCl is contributing to the pH. So we are going to use its molarity at this particular time in the titration to calculate the pH. So we are not using the initial molarity, which is 0.3126. That's not what we're using. We are using the molarity here at this time in the titration to calculate the pH. So we have to figure out what is that molarity. What is the ending molarity? We know the number of moles. The number of moles is 0.002815. What about the volume? What's the volume? At this particular time, in the flask, we had 10 milliliters of NaOH that we added, so that was one of the things that was in there. 10 milliliters of the NaOH. We also had, how much HCl did we have? We also had 25 milliliters of HCl. So we had these two solutions combined together to give us a total of 35 milliliters in that solution. So this is going to be our combined volume at the time E at the end. Let's rewrite that in a way that makes it easier for us to calculate molarity. 0.002815 moles of HCl over the 35 milliliters, or 0.035 liters. That works out to 0.0804 molar HCl. And remember, what we're trying to do here is calculate the pH. pH, the negative log of the H3O plus concentration. For a strong acid, the concentration of the acid is the concentration of the H3O plus. And the pH of this solution is 1.09. I know that this is really, really hard stuff. You guys are doing awesome.